Today we are looking few unique and strange planets. Each planet is unique in its own way, and characteristics that make a planet stand out can vary depending on the criteria used. This far-off blue planet may look like a friendly haven, but don't be deceived. Weather here is deadly. The planet's cobalt blue color comes from a hazy, blow-torched atmosphere containing clouds laced with glass. Howling winds send the storming glass sideways at 5,400 miles per hour, whipping all in a sickening spiral. It's death by a million cuts on this slasher planet. HD 189733b is a gas giant exoplanet that orbits a K-type star. Its mass is 1.13 Jupiters. It takes 2.2 days to complete one orbit of its star, and is 0.03 AU from its star. Its discovery was announced in 2005. The daytime temperature is nearly 2,000 degrees Fahrenheit, and it possibly rains glass, sideways, in howling 500 mph winds. The cobalt blue color comes not from the reflection of a tropical ocean as it does on Earth, but rather a hazy, blow-torched atmosphere containing high clouds laced with silicate particles. Silicates condensing in the heat could form very small drops of glass that scatter blue light more than red light. So here it is, HD 189733b, a blue planet, but not as we know it. Methuselah is known for being one of the oldest known exoplanets. The system it resides in, PSRB 162026, is estimated to be around 12.7 billion years old, which is considerably older than our own Sun and the Milky Way galaxy. The host system, PSRB 162026, is a binary system consisting of a pulsar, a rapidly rotating neutron star, and a white dwarf. The pulsar was formed from a massive star that exploded in a supernova. The formation of Methuselah is believed to be unique. It's thought to have formed through a series of interactions in the crowded core of a star cluster. The white dwarf and pulsar in the system likely played key roles in shaping the planetary system. Methuselah orbits both the pulsar and the white dwarf, creating a triple star system. Its orbit is highly elongated, and it takes approximately 100 Earth years to complete one orbit around both stars. Distance from Earth. PSRB 162026b is located in the constellation Scorpius and is situated about 12,400 light-years away from Earth. Gliese 436b is an exoplanet located in the constellation Leo, approximately 33.4 light-years away from Earth. Here are some key features and characteristics of Gliese 436b. Gliese 436b is classified as a hot Neptune or a warm Neptune because it is a Neptune-like exoplanet that orbits very close to its host star, Gliese 436. Gliese 436 is a red dwarf star with about half the mass of the Sun. The planetary system also includes other known objects, such as a smaller outer planet called Gliese 436c. Gliese 436b has an extremely close orbit around its host star, completing one orbit in about 2.6 Earth days. Its proximity to the star places it in the category of hot Neptunes, where temperatures can be quite high. Despite being close to its star, Gliese 436b exhibits an interesting characteristic. It seems to have a relatively low temperature for its proximity to the star. This could be due to the presence of a reflective cloud or haze layer in its atmosphere that prevents the planet from absorbing too much heat. The planet's atmosphere is believed to contain a significant amount of hydrogen and helium, similar to Neptune in our own solar system. It may also have a substantial amount of water in various forms, including a superyonic ice phase. The planet has shown some intriguing variability in its observations, with studies suggesting changes in its atmosphere or the presence of a comet-like tail of hydrogen escaping the planet. CoRoT 7b is an exoplanet discovered by the CoRoT satellite, a space telescope designed to detect the subtle changes in the brightness of stars caused by planetary transits. Here are some key features and characteristics of CoRoT 7b. CoRoT 7b is a rocky exoplanet often referred to as a super-Earth due to its size and composition. It is located in the constellation Monoceros, approximately 489 light-years away from Earth. CoRoT 7b is about 1.58 times the radius of Earth, making it one of the smallest exoplanets detected at the time of its discovery. It has a mass approximately 5 times that of Earth. The planet has a very close orbit around its host star, completing one orbit in just 20.4 hours. Its proximity to the star places it in a category of exoplanets known as ultra-short period planets, Corot 7b orbits a star named Corot 7, which is a G-type main-sequence star similar to our Sun, but slightly smaller and cooler. Due to its close proximity to its host star, Corot 7b experiences extreme temperatures. The side facing the star can reach temperatures as high as 2,300 degrees Celsius, 4,172 degrees Fahrenheit, while the dark side in perpetual night is much cooler. The planet is likely to have a rocky composition, and its surface could be covered with lava or molten rock due to the intense heat. It may lack a substantial atmosphere, and any atmosphere present would likely be stripped away by the star's intense radiation. Corot 7b is historically significant as one of the first rocky exoplanets discovered and characterized. Its detection marked a milestone in the study of exoplanets, especially those with sizes and compositions different from those in our own solar system. Gliese 581g is an exoplanet located in the Gliese 581 system, which is about 20 light-years away from Earth in the Libra constellation. Discovered in 2010, it has been of interest due to its location in the habitable zone of its host star. Here are some key details about Gliese 581g. Gliese 581g is classified as an exoplanet, and is often referred to as a potentially habitable planet because it orbits its host star in the habitable zone, where conditions may be suitable for liquid water to exist. It orbits a red dwarf star known as Gliese 581, which is cooler and smaller than our Sun. The star is part of a multi-star system with at least 6 known planets. Gliese 581g is estimated to be a super-Earth, with a mass several times that of Earth. Its size is still uncertain, and it is considered a tidally locked planet, meaning one side of the planet always faces its host. Star Gliese 581g has an orbital period of about 37 Earth days. Its close proximity to its host star raises questions about its potential habitability, as it might be subjected to strong stellar radiation and tidal locking effects. The habitable zone of Gliese 581g is a region where conditions might allow for the existence of liquid water, a key ingredient for life as we know it. However, the potential habitability of Gliese 581g is still a topic of debate and ongoing research. Tidal locking means that one side of the planet always faces the star, leading to extreme temperature differences between the day and night sides. Kepler-10b was discovered by the Kepler spacecraft using the transit method. This method involves detecting the slight dimming of a star's light when a planet passes in front of it. Kepler-10b orbits a star known as Kepler-10, located in the Draco constellation. The star is somewhat similar to our Sun, and the planet is one of several in the Kepler-10 system. Kepler-10b is a rocky exoplanet, meaning it has a solid surface. It is often referred to as a lava world because of its high temperatures. Kepler-10b is a scorched world, orbiting at a distance that's more than 20 times closer to its star than Mercury is to our own Sun. The daytime temperature is expected to be more than 2,500 degrees Fahrenheit, hotter than lava flows here on Earth. Kepler-10b is about 1.4 times the size of Earth, but has a mass more than 3 times that of Earth. It is considered a super-Earth. The planet completes one orbit around its host star in a relatively short period, taking only about 0.84 Earth days. Due to its close proximity to its host star, Kepler-10b experiences extreme temperatures. The surface temperatures are hot enough to melt iron. Kepler-10b's existence and characteristics were confirmed using additional observations and analysis, including radial velocity measurements. From a rocky inferno, we journey to a glittering treasure chest in the cosmos, the Diamond Planet. PSR-J 1719-1438b was discovered using radio pulsar timing observations. It orbits a millisecond pulsar known as PSR-J 1719-1438, which is a rapidly rotating neutron star. Nestled about 4,000 light-years away, it's not exactly a stone's throw away, but its unique characteristics make it worth the distance. It is an exoplanet that is believed to be the remnant of a once massive star. It is extremely dense, and its composition is thought to be mostly carbon and oxygen. Its density has to be more than 20 times that of Jupiter. The planet is most likely a remnant of a binary star which avoided complete destruction. The chemical composition, pressure, and dimensions of the planet indicate that it is crystallized. The exoplanet orbits its pulsar host in a tight orbit with an orbital period of only about 2 hours and 10 minutes. It is believed to be the remnant of a star that lost its outer layers in a process called mass transfer. The remaining core, now the exoplanet, is thought to be composed largely of carbon and oxygen in crystalline form. The nickname the Diamond Planet stems from a hypothesis suggesting that the high pressure and carbon-rich composition might cause the carbon to crystallize, forming diamond structures within the planet. However, direct evidence of diamonds on this exoplanet is challenging to obtain. The host star, PSRJ 1719-1438, is a rapidly rotating pulsar, emitting beams of radiation as it spins. The pulses of radiation from the pulsar were used to detect the presence of the orbiting exoplanet. The surface temperature of this crystal wonder is estimated to be a scorching 5,000 degrees Celsius. Not exactly the ideal location for a cosmic jewelry shop. Despite its inhospitable conditions, the Diamond Planet offers a fascinating glimpse into the diverse and often surprising nature of the cosmos. PSRJ 1719-1438b, a gem of a planet, quite literally. Next, we venture to a world where life as we know it may have a fighting chance, K218b. This super-Earth exoplanet, nestled about 124 light-years away, has piqued interest among scientists and space enthusiasts alike. Situated comfortably in the habitable zone of its star, K218b is the Goldilocks of exoplanets. Not too hot, not too cold, it's just right for water to exist in its liquid state, a crucial ingredient for life as we know it. But what sets this celestial body apart is not its location, but the tantalizing evidence of water vapor in its atmosphere. In the vast, seemingly inhospitable expanse of the cosmos, water vapor is a rare and precious commodity. Its detection on K218b has led scientists to believe that under the right conditions, this planet could potentially host life. Imagine an alien world with its own water cycle, clouds, and perhaps even rainfall. However, before we get too carried away with visions of extraterrestrial life splashing in alien puddles, it's important to note that this is all still speculative. The presence of water vapor alone does not guarantee life, but it does fuel our curiosity and drive our exploration further into the unknown. K218b, a beacon of hope in our search for extraterrestrial life. The planet HD 106906b. This exoplanet dances to its own celestial tune, orbiting its host star from an astonishing distance of about 650 astronomical units. To give you a sense of scale, 1 astronomical unit is the distance from our Sun to our beloved Earth. Now imagine 650 times that. Quite a leap, isn't it? This peculiar positioning of HD 106906b defies the conventional wisdom of planet formation. The traditional theories suggest that planets are born in the dusty, gaseous disks that surround young stars, gradually pulling together solid material to form a celestial body. They are expected to orbit relatively close to their star, much like the planets in our own solar system, but HD 106906b, with its extraordinary distance, challenges this understanding. Could it be that this planet was formed closer to its star and was later flung out to its current position by gravitational interactions? Or perhaps it formed in situ, right where it is now, suggesting a whole new method of planet formation? Scientists are still unraveling this cosmic mystery. This outcast planet with its defiant orbit forces us to rethink our understanding of the universe, and in doing so, it reminds us of the vastness and complexity of the cosmos. HD 106906b, a planet that dares to defy the norms of our cosmic understanding.